Hello viewers, my name is Dr. Ajay, Associate Professor, Department of ECE, Institute of Aeronautical Engineering College, Hyderabad. So today's topic is problems on critical frequency and skip distance. So let us do some problems on critical frequency and skip distance. And this topic is related to the course Antennas, Waves and Propagation. So this topic is related to the course Antennas, Waves and Propagation. And let us start our session today. So if the maximum electron density for E layer in ionosphere is 9 into 10 power 6 electrons per centimeter cube, calculate the critical frequency here. So here the maximum electron density, it is given as N max. We denote it by the symbol N max. So N max is equal to, it is given as 9 into 10 power 6 electrons per centimeter cube. And we need to calculate the electron density for the E layer. So here we need to have an idea whether the units are given in centimeter or meters. So we are going to calculate in the SI unit the frequency. So we know that there is a relationship between the critical frequency and the ionization density or the electron density. So the electron density or the ionization density both are having the same meaning. So the relationship between the critical frequency and the ionization density is given as 9 into root N max. 9 into root N max here. So what is N max here? So N max, it is given as 9 into 10 power 6 electrons per centimeter cubed here. So we can also calculate this in terms of meters cubed by 9 into 10 power 12 electrons per meter cubed. So just we have converted this N max into the meters units, that is 9 into 10 power 6 electrons per meter cubed. So we need to calculate the value of Fc now. So what is Fc here? Fc is equal to 9 root N max. Fc is equal to 9 root N max here. Let us simplify this. 9 square root of N max means 9 into 10 power 12. So 9 into 10 power 12 here. So if we simplify this, we will get 9 into root of 9 into 10 power 12 means root 9 means it is 3. And root 10 power 12 means it is 10 power 6 here. So this equal to, will get 27 into 10 power 6. So 10 power 6 means it is mega. So the value of Fc, that is critical frequency, can be written as 27 into 10 power 6 hertz. So this can be further simplified as 27 mega hertz here. 27 mega hertz here. So this is how to simplify the value. So Fc is equal to 9 root N max here, simply. So we know that Fc is equal to 9 root Nm or N max. So here N max is given as 9 into 10 power 6 or 9 into 10 power 12. So 9 into 10 power 12 is equal to 9 into 3 into 10 power 6 is equal to 27 megahertz. This is Fc. So Fc stands for critical frequency. Fc stands for critical frequency. Now let us go to the next problem here. At a particular daytime, the critical frequencies observed for E and F layers are 2.5 MHz and 8.5 MHz respectively. So here the critical frequency during the daytime, it is noted as 2.5 MHz, and FC during the night time, it is noted as 8.5 MHz. 8.5 MHz. Now we need to calculate the maximum electron density of both layers per cubic centimeter. per cubic centimeter here. So what is the maximum electron density of both layers in per cubic centimeter here? So let us calculate the values as by applying the formula. We know that Fc is equal to 9 root n max. Fc is equal to 9 root n max here. Now for the daytime, the Fc value is given as 2.5 into 10 power 6. It is given as 2.5 into 10 power 6. This is equal to 9 root n max here. So here 9, if you take this to the left hand side, you will get root n max is equal to 2.5 into 10 power 6 by 9. So squaring on both sides, you will get n max is equal to 2.5 square into 10 power 12 whole divided by 81. So 25 into 25 you will get 125, 1.25 here, 1.25 into 10 power 12 divided by 81 here. So if you simplify this value for daytime, the n max value you will get as 0.7716 into 10 power 12 per meter cubed. 10 power 12 per meter cubed here. And similarly, night times, Fc is equal to 9 root n max. It is given, for night times it is given as 8.5 into 10 power 6 is equal to 9 root n max, and root n max is equal to 8.5 into 10 power 6 whole divided by 9. And squaring on both sides, you will get n max is equal to 8.5 whole square into 10 power 6 whole square divided by 9 square. So divided by 9 square. So if you simplify this, you will get 0.8919 into 10 power 12 per meter cubed here. So like this, we need to find out the values of n max based upon the daytime or night times here. So this is the problem we are having here. So based upon this problem, we are going to extend this problem to obtain the change in the densities. So we are going to find out the change in the electron densities based upon this problem also. Now determine the change in the electron density of the E layer when the critical frequency changes from 4.5 MHz to 1.5 MHz between midday and sunset periods. So here the daytime critical frequency is given as 4.5 MHz, and during the sunset the critical frequency is given as 1.5 MHz. Now we need to find out the values of change of electron density. That means that we need to find out the electron density. Let us assume that as n max 1 for daytime. For sunset, it is assumed as n max 2. Assume the electron density for the daytime as n max 1. Assume the electron density for nighttime or sunset as n max 2. Now change in these two. So change in these two means the change of electron density is nothing but n is equal to n max 1 minus n max 2 here. So n is equal to n max 1 minus n max 2 here. Now let us simplify this problem here. So here Fc is equal to root of 81 n max. Call this as equation 1. And here let us assume for a daytime, for midday time, Fc1, assume the critical frequency as Fc1. So the general formula is Fc is equal to root of 81 n max. For daytime, we are assuming the critical frequency as Fc1 is equal to root of 81 into n max 1. So Fc1 is given as 4.5 into 10 power 6 is equal to 9 root n max 1 here. Assume this as 2 here. Let us assume this as equation 2 here. Now again, the second frequency during sunset is given as FC2. Assume as FC2 is equal to root of 81 n max 2 here. Let us assume the FC2 value is given as 1.5 into 10 power 6. It is given as 1.5 megahertz. The critical frequency during the sunset is given as 1.5 megahertz. This is equal to 9 root n max 2. Assume this as equation 3 here. Now let us add equations 2 and equation 3. Add 2 and 3. So if we add these two, we will get 4.5 plus 1.5 into 10 power 6 is equal to 9 root n max 1 plus 9 root n max 2 here. 9 root n max 1 plus 9 root n max 2 here. So if we simplify this, we will get 6 into 10 power 6 is equal to 9 root n max 1 plus 9 root n max 2 here. So assume this as equation 4 here. So by adding 2 and 3, we got equation 4. That is 6 into 10 power 6 is equal to 9 root n max 1 plus 9 root n max 2 here. Now similarly, let us do subtraction 2 minus 3 here. So if we simplify subtracting 2 and 3, you will get 4.5 minus 1.5 into 10 power 6 is equal to 9 root n max 1 minus 9 root n max 2 here. So 4.5 minus 1.5 means it is 3 into 10 power 6. This is equal to 9 root n max 1 minus 9 root n max 2. This is equation 5 here. So let us add 4 and 5 here. So what is the fourth equation here? This is 6 into 10 power 6. So 6 into 10 power 6 is equal to 9 root nm1 minus 9 root nm2. This is plus here for equation 4. And this is 3 into 10 power 6 is equal to 9 root nm1 minus 9 root nm2. So nm1 and nm2 stands for n max 1 and n max 2. Here these two get cancelled. If these two get cancelled, what is the remaining term? So we'll get n max 1 here. So 9 into 10 power 6 is equal to 18 root n max 1 here. So from this equation, you will get n max 1. N max 1 is equal to 0.25. So n max 1 is equal to 0.25. You will get something into 10 power 12. And similarly, we are going to find out by subtracting equations 1 and 2. So by subtracting equations, these two equations, here we have added the equations 4 and 5. So we are adding equations 4 and 5 here. We got next we will do 4 minus 5 here. So we do 4 minus 5. You will get 4 minus 5. Let us do simplify 4 minus 5 here. If you simplify this, you will get 6 minus 3 into 10 power 6 is equal to 18 root n max 2. So 6 minus 3 means 3 into 10 power 6 is equal to 18 root n max 2 here. Squaring on both sides, simplifying, you will get n max 2 is equal to 0.02778 into 10 power 12. So according to the problem, we need to find out the change of densities. That means n is equal to n max 1 minus n max 2 here. So n max 1 we got as 0.25 into 10 power 12 minus 0.02 n max 2 7 into 10 power 12. So you will get overall 0.222 into 10 power 12 per meter cubed here. So here what we have did, during the daytime and during the sun time, we are going to determine two different values. One is n max 1 the electron density and n max 2 the electron density during the sunset, and the difference of these two n max values gives the change of density with respect to the frequencies varied from daytime to the sunset time. So this is the problem as per the data given. So we are adding the two equations. We have the two equations, we will get this equation, and if we simplify, you will get n max 2, and the difference of n is equal to n max 1 minus n max 2, you will get 0.222 into 10 power 12 per meter cubed here. Let us do another problem. So at what frequency a wave propagates in the D region to have index of refraction as 0.5 if the electron density for the D region is 400 electrons per centimeter cubed. Here the data is given as, directly the data is given as mu. So mu is equal to 0.5. The number of electrons is equal to 400 electrons per centimeter cubed. Let us convert this into SI units per meter cubed as 400 into 10 power minus 6 electrons per meter cubed. So we need to find out the frequency. So there is a relationship between the electron density and the refractive index, which is given by mu is equal to 1 minus 81 n by f square. So mu is equal to 1 minus 81 n by f square. The value of mu it is given as 0.5 here. The value of mu it is given as 0.5. Substitute the value of mu here, and the 1 as this 1 you can write it, and 81 into n value is 400 into 10 power minus 6 by f square. So here squaring on both sides you will get 0.5 whole square is equal to 1 minus 81 into 400 10 power minus 6 by f square. So here just we can see here mu is equal to root of 1 minus 81 n by f square here. So the value of mu is given as 0.5. This is equal to root of 1 minus 81 into 400 into 10 power minus 6 divided by f square here. So squaring on both sides you will get 0.5 whole square is equal to 1 minus 81 into 400 into 10 power minus 6 whole divided by f square here. Whole divided by f square. So if you simplify this, you will get f square is equal to 81 into 400 into 10 power minus 6 whole divided by 0.75 here. So taking the square root on both sides, you will get the value of f as 0.02078 mega hertz here. So there is a relationship between the refractive index and the ionization density, which is given by mu is equal to root of 1 minus 81 n by f square, which is given as 0.5 is equal to square root of 1 minus 81 n by f square here. So if you simplify this, what you will get? 400 into 81. So this is equal to 1 into 400, 400, 80, 0, 8 4s are 32. So you will get 32,400 here. So you will get 32,400 here. So here 32,400 into 10 power minus 6 divided by 0.75. So if you take the square root here, you can apply for square root here. So for 32,400 into 10 power minus 6 by 0.75, if you simplify, you will get the value as 0.2078 mega hertz here. So these are the we have discussed here. So we have discussed about the problems on electron density and change of density, and also the problems on critical frequency. So for all these problems, you can refer these textbooks for references. These are the textbooks which are you can do the problems from these textbooks of Bakshi, and also K.D. Prasad, that is Satya Prakashan, 2001. And for more complex problems, you can also refer the Balanis textbook if you want to do more problems, and also you can also refer John D. Cross. Antennas, waves and propagation by Balanis, and also the antennas, waves and propagation by John D. Cross. So these two problems you can refer for more number of problems. Let us close the session today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.